So this is the last section or a little part of Chapter 7 review for the final. Looking at rational functions and determining if they have vertical asymptotes and or points of discontinuity, which are holes in a graph. So there's also horizontal asymptotes as well as oblique, but we're not going to be looking at that for the final. We're just looking at vertical and points of discontinuity. So to find vertical asymptotes, we want to see what makes the denominator equal to 0. When the denominator is equal to 0, you cannot evaluate at that point. So it has a vertical asymptote, a dashed line going up and down. So this is equal to 0 when x is equal to 5. And the graph of that, actually I'm going to make a separate video that shows the graphs of these. So make sure you check that out as well. Points of discontinuity, there's no points of discontinuity here. It's when there's a hole in the graph, and a point of discontinuity means you need to have the same thing in the numerator and denominator that cancels out. So there's nothing here for that. For part B, we've got a quadratic in the denominator. So first we want to factor that. 3x, x, we've got 2 and 1, so that's going to be plus 2 minus 1. That's 6x minus x is positive 5x. And then in the numerator, we can factor out the 3. 3 times x plus 2 over 3x minus 1 times x plus 2. And this is f of x equals, they both have numerator and denominator, both have x plus 2. So because they both have that, when this is equal to 0, that's going to be a point of discontinuity. So x plus 2 is equal to 0 when x is equal to negative 2. So there's going to be a point of discontinuity when x is negative 2. We're asked to find the value xy, so we have to also find the y coordinate. Let's hang on for that and first look to see what the vertical asymptote is, if there is one. So when we cancel out x plus 2 over x plus 2, we're left with 3 over 3x minus 1. And again, vertical asymptote is when the denominator, what's left over, is equal to 0. So if we set 3x minus 1, the denominator equal to 0, we get 3x equals 1, so x equals 1/3. And again, vertical asymptote, it's a vertical line. So a vertical line would just be when x is equal to 1/3. For the point of discontinuity, we want to take this function that we're left with and plug in the x coordinate to find the y coordinate. So f of negative 2 equals, that's 3 over 3 times negative 2 minus 1, which is 3 over negative 6 minus 1 is negative 7. So that's negative 3/7. So we've got a vertical asymptote and a point of discontinuity. And then the last one, we have a quadratic over another quadratic. So we want to factor this, 2x and x over x and x. So to get to 3 multiplied to negative 4, we want 2, 1, it's going to be positive 4x minus 1x gets you 3x and multiplies to negative 2, so that's good. In the denominator, this is x minus 5 times x plus 2. And look to see if the numerator and denominator both have any binomials the same. If they do, then that's a point of discontinuity. And this one happens to be the same as part B. The point of discontinuity is when x plus 2 is equal to 0. So x plus 2 equals 0. That means x is equal to negative 2 is a point of discontinuity again. So that's the x coordinate. And find the vertical asymptote, see what we're left over with after we cancel the point of discontinuity out. That's 2x minus 1 over x minus 5. This is the function that we're left over with. So we want to see, okay, what makes the denominator equal to 0? Whatever makes the denominator equal to 0 is going to be a vertical asymptote. So that's x equals 5 is our vertical asymptote. And the point of discontinuity, we can plug negative 2 into the function, what was left over. F of negative 2 equals 2 times negative 2 minus 1 over negative 2 minus 5. That is negative 5 over negative 7, or just 5/7. That's our point of discontinuity. So if you would like to make more sense of this, check out the third video, which goes over Desmos and what these graphs look like. Thanks for tuning in.